I'd like to show you how to solve formulas for one of the variables, and this will be 1.4a when you get onto Hawks. And a very simple formula that you can solve for a variable is distance equals rate times time. And we want to solve that for r, which is rate. So that means I want to end up with r equals and some business on the right hand side, but I want only r on the left hand side. So to get that, I do opposite operations, and I can see here that r is being multiplied by t. So I do the opposite, which is to divide by t, and because it's an equation, of course, I have to do the same thing for both sides. Now on the right hand side, the t's reduce, and I'm left with d over t equals r. So distance divided by time equals the rate. And that is solved for r. I can leave it in this form, or I can just flip it over and write it r equals distance over time. And that is my formula solved for r. Now here's a little bit more complicated one. I want to solve for y, so I need to find where is the y in my equation, and I want to get the y by itself. And I have some fractions, so I can clear my fractions at the very beginning and then solve for the y, or I can work with the fractions. So I think I'd like to clear my fractions at the beginning. So I look at my two denominators. I have a 2 and I have a 4, so I can see since 2 goes into 4 that 4 should be my LCD. And so what I want to do is multiply both sides by the 4, and remember I will have to distribute it, and multiply the right hand side by the 4 as well. Now on the right hand side my 4's reduce, which is very handy. You can think of it as 4 over 1. On the left hand side I have to do a little bit more work, and that's to distribute. So 4 over 1 times 1/2 x plus 4, and I don't need it over 1 here because I don't have any fractions on this term, 4 times 3y, and that's equal to just a 5. That's all I have left on the right hand side. Now when I multiply 4 over 1 times 1/2, this 2 goes into the 4 2 times, and I have 2 times 1, or 2x. And then here 4 times 3, there's nothing to reduce, I just have a 12y equals 5. Now I want the y by itself again, so since this is a whole term that's being added to the term with the y, I'll go ahead and do the opposite. It is a positive 2x, so I'll subtract 2x from both sides. And these, of course, give me 0, and I have 12y equals. Now if these were like terms I would combine them, but since they aren't, there's no x on here and there is an x here, so they cannot be like terms, so I just write them 2x plus 5. And I really like to put the term with x first and the constant second, because this is closer to the y equals mx plus b form that we'll use when we're graphing. Then I want to get the y by itself still, and 12, when it's smashed up next to something, means it's being multiplied. So I'll go ahead and divide by 12. That's the opposite operation, and I'll have to do that on every term. The 12's reduced to 1, of course, and I have, if I come up here to write y equals, and I have negative 2 divided by 12. Well, it doesn't come out to a whole number, but it does reduce. Divide by 2 top and bottom, and I have negative 1/6 x, and the 5/12 is not going to reduce at all, is it? So there's my answer. It's in terms of y equals, so I know I have solved the linear equation for y. So I have y equals, and then everything else legally moved to the right hand side. So there's my answer right there. Now here's another one, and I have 1/2 h times this quantity b plus c. And I'd really like to get rid of this fraction. So remember, if I have 3 times 2 times 5, I can choose and say I also want to multiply by another 4 out front, for example. I can choose to multiply these two first and write 12, and then multiply the next two and get 24, and then multiply the last pair here and I get 120, I believe. Now, applying that to this problem, I have a 1/2 and I'd really love to clear my fraction, and I know because I have a denominator of 2 that I can multiply both sides of this equation by a 2. So I'm multiplying both sides of the equation by the same number. On the left, I just end up with a 2a. On the right, I'm going to choose, like I chose over here, which two to multiply together first. I'm going to choose to multiply these two together because I know that 2 is the same as 2 over 1. And when I multiply it by 1/2, my 2's reduce, and all I'm left with there is a 1. Now I chose to multiply those two together and get a 1, and that's what's being multiplied by the h times this quantity here. What h times 1 is just an h. I have moved the 1/2 over to the left-hand side and it becomes a 2a. Now I still want to get, I'm looking for c, so I want to get this one free of this quantity. So I'm thinking again about this h. It's being multiplied by that quantity. So I want to go ahead and do the opposite, which is divide both sides by h. My h's reduce, and I have 2a over h equals a b plus c. Now I still want this c by itself, and since I'm adding or subtracting here and the b is positive, I will go ahead and subtract b from both sides. And these are nowhere near like terms, so the best I can do is write them out. 2a over h minus b equals, and positive b plus negative b is 0, of course, and then I just have a positive c left. So here's my answer. I can, of course, rewrite it with the c equals on the left if I choose, but they're completely equivalent. Either one of these two would be perfect. Now, if you'd like to, you could try one of these problems here. Go ahead and pause the video and work those, and then when you're ready to check out my answer, you can restart. I'm guessing that we're ready now to see how to solve these. So I want the h by itself, and I think what's the operation in between these three letters, and since they're all smashed together it means multiply. To do the opposite I would have to divide, so I will divide by both of the things I want to move away, the L and the W. And I have to do it on the left hand side to keep it equivalent. My LW reduces top and bottom, and I'm left with h equals v over LW. And I'm finished. Now, my next one, I can slide this up a little bit. Yeah, I want to solve for the y. So I want to move this whole term to the other side. Since it's addition, I need to think, is it a positive 3x or a negative 3x? And it is positive, so I'll add the opposite, or add a negative 3x or subtract 3x, however you want to look at it. From both sides, of course, these come to 0 and I'm left with a positive y equals, remember I'd like to have my x term first, negative 3x, and there was a positive 8 sitting there. So my answer is y equals negative 3x plus 8.